Hi, my name is Kate Berry from the University of Texas at Austin, and welcome to this video for our Pirate Math Equation Quest multi-step word problem intervention with total, difference, change, and equal groups problems. In this video, I'm going to model how to set up and solve 3 different types of multi-step equal groups and equal groups problems. Here in our multi-step word problem intervention, we have 5 different lesson components: Captain Cards, Equation Quest, Buccaneer Problems, Ship Shape Sorting, and our Jolly Roger Review. Students set up and solve word problems during our Buccaneer Problems and our Jolly Roger Review. For the purposes of this video, I'm going to focus on Buccaneer Problems, where students set up and solve word problems with the tutor or teacher as a guided practice opportunity. So as we work through multi-step word problems with equal groups and equal group schemas, we're really thinking about those Buccaneer problems. Here are the materials you will need: your multi-step word problem schema mat version 3 that has our equal groups and equal groups equations, your Buccaneer Problems worksheet, a pencil, and then the What Do You Ask Yourself poster, which will help us differentiate across the 4 different schemas. When we're thinking about multi-step word problem interventions, we really took a close inventory and looked at all of the different multi-step word problems that were featured at grades 3, 4, and 5. And what we noticed was 4 different schema combinations were most prevalent: total and difference, total and equal groups and equal groups, and equal groups and total and equal groups and difference. So equal groups total, equal groups difference. In this video, I'm going to focus on multi-step word problems that include the equal groups and equal group schema 2 times. So here, this is a zoom in of our multi-step word problem intervention poster. When students are solving multi-step word problems with the equal groups and equal group schemas, we see 3 different types of equations. Our first equation, open parentheses, GR times N, close parentheses, times N equals the product, stands for the groups times the number in each group times the number in each group again. In this first example, we have an unknown product twice. In our second example, it says open parentheses, GR times N, close parentheses, divided by GR is the same as blank. So the groups times the number in each group divided by the number in each group, divided by the number of groups rather, equals or is the same as blank. In our last example, we see our equation is open parentheses, P divided by GR, close parentheses, divided by GR is the same as blank. So here students are dividing twice because we have a known product 2 times. So one equal groups multi-step combination would be that students are multiplying twice when we have an unknown product twice. Another combination would be when students are multiplying and then dividing when we have an unknown product followed by a known product. And then our last example, a student would be dividing twice if we have a known product 2 times. So we can think the 3 different variations: multiply twice, multiply and then divide twice. You can see here our equations in another way. And on the following slides, what I'm going to do is model how to set up and solve each of these 3 different variations of multi-step equal groups and equal groups problems. So let's take a look at our first example. First, we always want to check for a table or a graph. I don't see a table or a graph, but if I did see a table or a graph, I would number it. So I'm going to go ahead and grab my marker so we can write our attack strategy. So here I'm going to write UU, PP, SS, check, check. Marker is a little squeaky, but we can make it work. Our first U stands for understand by reading, so let's read our problem. It says there are 5 ounces of soda in a can. There are 10 cans of soda in a case. How many ounces of soda are in 3 cases? I feel like I've understood the problem. I'm going to check off my first U. My second U is to underline my label. Most of the time I can find the label in the question sentence, which starts with a capital letter and ends with a question mark. This says how many ounces of soda are in 3 cases. I know they're asking me about ounces of soda, so I'm going to go ahead and underline that in our question sentence. Now that I have underlined my label, I can move to my first P and put parentheses around needed numbers. If you want to cross out any irrelevant information in that first or that second use step, you can, or you can wait until you get to your first P. If you start scanning the numbers and seeing something that's irrelevant, you can cross it out at that time. But let's go ahead and scan our numbers. Our first number is 5. That's about ounces of soda. That matches my label, so I know I need that number. So I'm going to put that in parentheses. My next number is 10. That's about cans of soda. But cans of soda are related to ounces of soda. We're all talking about soda and ounces and cans and cases. So that's relevant. I know that I need that number. So I'm going to put that also in parentheses. And then my last number is 3. 3 is about cases. That's not talking about ounces of soda, but we're trying to figure out the ounces of soda in 3 cases. So because it's related, I'm also going to put that in parentheses and check off my first P. Now my second P stands for put the numbers in order. When we were working with single step problems, it was super easy because we could just put a 1 above our numbers. But now we're thinking about multi-step problems. So we have to think hard about what's happening first in the problem and put a 1 above those numbers. And then we have to think about what's happening second and put a 2 above any numbers that relate to what's happening second in the problem. So let's read our first 2 sentences so we can get an idea of what's happening. It says there are 5 ounces of soda in a can. There are 10 cans of soda in a case. So here I need to figure out how many ounces of soda are in 10 cans. So because I'm dealing with 10 cans of soda and 5 ounces in each of those cans, I'm going to put a 1 above those 2 numbers. Then I need to figure out how many ounces of soda are in 3 cases. So once I found out how many ounces of soda are in 10 cans, I need to figure out how many ounces of soda are in 3 cases. So the second thing I'm doing is focusing on those 3 cases. So I know first I'm figuring out how many ounces of soda are in 10 cans, and then how many ounces of soda are in 3 cases. So I'm going to check off that second P to help me know that I've put my numbers in order. I'm dealing with these first 2 numbers first, and then the 3 cases second. Now I can move to my first S, which stands for schemas. We always teach students to use our What Do You Ask Yourself poster to question and gesture so that they can help distinguish among the schemas and figure out what's happening in our problem. So we like to say, are parts put together for a total? Are 2 amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? We said first we know that there are 10 cans of soda, and we know there are 5 ounces in each can. So I have groups, which are my 10 cans of soda, and I have my number in each group, which is the ounces of soda in each can. So I know my first step is going to be equal groups here with a missing product. I'm trying to figure out how many ounces of soda are in 10 cans. We have the 10 cans of soda and 5 ounces in each can. Then we have to figure out what our second step is. So I'm going to put a 2 here, and it says how many ounces of soda are in 3 cases. So once we figure out the ounces of soda in 10 cans, we then need to figure out the ounce of soda in 3 cases. So we have another example of equal groups where our product is missing, because we have groups, which are our 3 cases, and then we have the ounces of soda in each case. So I'm going to put an EG again to let me know that I'm dealing with equal groups and equal groups. But I'm not finished with my schema. I still need to look at my poster and figure out which equation I'm using. Because I'm multiplying twice and I have an equal groups problem with a missing product, equal groups problem again with a missing product, I know that I'm going to use my first equation, because in my first equation I see that I'm multiplying twice. So I'm going to do open parentheses, GR times N, close parentheses, times N is the same as blank. So first I'm going to figure out the amount or ounces of soda in 10 cans, and then I'm going to find out from there how many ounces of soda are in 3 cases. So here I know that my groups are the 10 cans of soda, and I know that I have 5 ounces of soda in each can. I can go ahead and check off that first S to let me know that that schema step is finished. I like to check off my numbers after I use them. And then here I have 3 cases. I'm going to check that off there. And now all I need to do is bring down my signs and my parentheses and press or have my blank here. Now we teach students about the order of operations, and we teach them that what's in parentheses is what we do first. So here I have 10 times 5, that's what's in parentheses. 10 times 5 I know is 50. 50 times 3, we could write it vertically. I'm going to do the mental math. I know that that's 150. Here I have my number answer, but I'm not finished. I still need my label. We also can check these off. My label, I said, was ounces of soda. I don't want my number to be lonely, so I need to write my label ounces of soda. I have my number answer and my label answer, and soda is kind of scooting off the page, so I'm going to write it again down here. Now I need to just check for reasonableness. I need to make sure that my number answer and label answer make sense. So I have 10 cans of soda and 5 ounces of soda in each can. It would make sense that I had 50 ounces of soda. But then I want to know how many ounces of soda are in 3 cases. So I'm going to multiply 50 times 3. That makes sense that I would have 150. So I know my number answer makes sense. My label, ounces of soda, matches what I underlined in the top in my problem, so I know my label makes sense. Nice job solving this equal groups and equal groups problem where we had a missing product 2 times. We're going to take a look at another example in the next slide. Now let's take another look at a multi-step equal groups and equal groups problem where we have to multiply and then divide. First, I'm going to take a look at my word problem. I do not see a table or a graph. If I did see a table or a graph, I would number it. So I'm going to go ahead and write my UPS check squared letters on the side here as a guide for me to work through my problem. So my first U stands for understand by reading. I'm going to go ahead and read the problem. This says Miss Levine bought 10 bags of candy. Each bag contained 8 candies. She put an equal number of candies into 2 jars. How many candies did she put into each jar? I read my problem. I'm going to check off my first U. Now I'm going to move to my second U, which stands for underline my label. I most of the time can find my label in our question sentence, so let's read it. How many candies did she put into each jar? We're talking about candies. Now I want some candy. We're underlining candies. That's our label. That's what we're talking about. I have underlined my label. If we want to check for irrelevant information in this step, we can. We also can check in our next step, put parentheses around needed numbers. In this step, I'm going to scan my numbers to make sure they're all talking about or related to candy. If there are not numbers talking about or related to candy, I'll cross them out. So let's scan our numbers. Our first number is 10. That's about bags of candy. That's related to candy. So I'm going to go ahead and put parentheses around 10 bags of candy. My next number is 8. That's about candies. So I'm going to put parentheses around 8 candies. We always want to put parentheses around the number and the word. Now I have 2. Well, 2 is not about candies, but I'm putting the candies into the jars. So that's actually related to my label. I need it because I'm actually putting the candies into the jars. I have put my parentheses around my needed numbers. It turns out I do need all of my numbers and I don't have any irrelevant information. Now my next P stands for put my numbers in order. When we were working through single-step problems, it was easy. We could just put a 1 above our numbers. But now with multi-step problems, we really have to think hard about what's happening first in the problem and what's happening second. We're going to put a 1 above the numbers involved in what's happening first in the problem and a 2 above the numbers that are involved in what's happening second in the problem. So let's go ahead. I like to read our first 2 sentences so we can really think about what's going on first. It says Miss Levine bought 10 bags of candies. Each bag contained 8 candies. So first we're really thinking about the total number of candies that we have. So I'm going to put a 1 above the bags of candies and the 1 above the 8 candies. And then it says she put an equal number of candies into 2 jars. So after I have to figure out how many candies we have all together, I know that I'm going to be putting them into the jars. So the second thing I'm going to be doing is putting them into the jars. I'm going to put a 2 right there. Now that I have put their numbers in order, I can check off that second P and move on to the S, which stands for schemas. We always like to direct students to our What Do You Ask Yourself poster so we can question and gesture and think about our schemas. We like to say, are parts put together for a total? Are two amounts compared for a difference? Is there a starting amount that increases or decreases to a new amount? Or do we have groups with an equal number in each group? So let's break this down. It first says Miss Levine bought 10 bags of candies. Each bag contained 8 candies. So first I need to figure out how many candies she has. Well, she has 10 bags of candies and 8 candies in each bag. I know that I have groups, which are my 10 bags, and a number in each group with a missing product. So I know that my first schema is going to be equal groups. Here, then it says she put an equal number of candies into 2 jars. How many candies did she put into each jar? So I have all my candies and I'm sharing them equally among 2 jars. When I'm sharing items equally, I know that I have an equal groups problem, but I know my product. I know my product or my candies and I'm sharing them equally among the jars. So my second schema is also equal groups, but in the second schema, I know my product. In the first schema, I don't know my product. So now before I move on to my S, I need to look at my poster and I need to think about which equation I'm using. When I don't know my product, I'm multiplying, and when I know my product, I'm dividing. So all I need to do now is figure out which equation has multiplication and then division, or which equation shows a problem where we have an unknown product followed by a known product. And if I look here at the second equation, I see that that's the one I'm looking for because I see the multiplication and then division. So here I'm going to write that equation, GR, or the groups, times the number in each group, divided by the groups again is the same as blank. Now I have figured out my schema and my equation, so all I need to do is plug in my numbers. We first have groups with the number in each group. We have a 1. One's above these 2 numbers. That's going to be a clue they go in parentheses because whatever we do in parentheses is what we do first. Whatever comes in parentheses, rather, is what we do first. I know my groups are the bags of candy. And I know that there are 8 candies in each bag. That's my number in each group. So I'm going to check off my 10 and my 8. Now, once I know the total number of candies, I'm dividing them into, or sharing them into 2 jars. So I'm going to check off that too. Now all I need to do is bring down my signs and my parentheses, and I'm good to solve. Whatever is in parentheses is what we do first. We teach students to follow the order of operations. 10 times 8 is 80. Now I'm going to divide by 2. You could have students set this up, but I can do that mental math. 80 divided by 2 is 40. I have my number answer, but that number is lonely. I need a label or a buddy. I underlined candies in my question sentence, so that's what I'm going to write here, 40 candies. So there are going to be 40 candies in each of our jars. Now the very last thing we need to do is check for reasonableness. Does my number answer make sense, and does my label answer make sense? So let's take a look. First, we have 10 bags of candies and 8 candies in each bag. It makes sense that I would have 80 candies. Now if I have 80 candies and I'm sharing or dividing them equally into 2 jars, it makes sense that I would have 40 candies in each jar. My label candies matches what I underline, so I know my number and label answer makes sense. Nice job solving this equal groups problem where we multiplied and divided because we had an equal groups example with an unknown product followed by an equal groups example with a known product. Join me in the next example where I will model how to set up and solve a multi-step equal groups problem where we're dividing twice, meaning we have an equal groups problem with a known product followed by an equal groups problem with another known product. I'll see you shortly. So let's take a look at our last example of a multi-step equal groups and equal groups problem with a known product 2 times. First, I'm going to look. I don't see a table or a graph. If I did see a table or a graph, I would number it. So I'm going to go ahead and write our UPS check. Marker's a little squeaky, but we're making it work. UPS check squared steps on the side. I'm going to follow my steps. My first U stands for understand by reading. I'm going to go ahead and read the problem. It says Jen has 50 marbles. She keeps an equal number of marbles in 5 bags. Each bag has half as many rocks as marbles. How many rocks are in each bag? I feel like I understand the problem. I'm going to check off my first U. My second U stands for underline the label. Frequently, the label can be found in our question sentence. It says how many rocks are in each bag. They're asking me about rocks. I'm going to go ahead and underline rocks. Check off my U. I've underlined my label. If you want to check for irrelevant information during this step, you can, or you can wait till your first P, which stands for put parentheses around needed numbers. So what I'm going to do now is scan my numbers and make sure that they're all talking about or related to rocks. So our first number is 50. That's about marbles. That's not about rocks, but it's talking about half as many rocks as marbles. So I know that it's related to our label because we're talking about not just rocks, but also marbles. So I'm going to put parentheses around 50 marbles. I'm going to keep going. Our next number is 5. 5 is talking about bags. That's related to rocks because we're talking about the rocks in the bags and the marbles in the bags. So it's a kind of a good learning moment to talk to students about how even if it doesn't say rocks, we have to think about if those numbers are related to what's happening in our story. In this case, they are, so we don't have any irrelevant information. So we can check off that P. One other thing I would challenge you to do here, it says each bag has half. I'm going to go ahead and actually put parentheses around half because that's actually another number that we need. When we have half, we could put 1/2 written right here. Okay, I know that's kind of hard for you to see, but always want to put any words like half in parentheses. Our second P, I got a little ahead of myself, is put our numbers in order. When we had single step problems, we just could put a 1 above our numbers, but now that we have multi-step problems, we need to put a 1 above whatever is happening first in the problem and a 2 above whatever is happening second. So we really need to think a bit harder about what's going on. So let's reread our first story. The beginning, it says Jen has 50 marbles. She keeps an equal number of marbles in 5 bags. So first we want to figure out how many marbles are in each bag. So we're talking about the marbles in the bags. So I'm going to put a 1 above these two numbers. Then it says each bag has half as many rocks as marbles. How many rocks are in each bag? So now I'm talking about half as many rocks as marbles. So I'm going to put a 2, and I'm just going to put that next to there. You know what I'm talking about. So we're figuring out that they're half as many rocks. After we figure out how many marbles are in a bag, then we need to half that to figure out how many rocks we have. Since we have half and that relates to rocks, that's the second thing happening in our story, so I put a 2 next to half. Now I can catch myself up and put a check mark next to that P. Now I'm going to move to the S, which stands for schemas. We always teach students to look at our What Do You Ask Yourself poster and question and gesture. We like to say our parts put together for a total, are two amounts compared for a difference, is there a starting amount that increases or decreases to a new amount, or do we have groups with an equal number in each group? So here it says Jen has 50 marbles. She keeps an equal number of marbles in 5 bags. So here we know we have our product, which is our 50 marbles, and our bags, which is our group. We don't know the number in each group. She's sharing these marbles equally among the 5 bags. So I know that I'm going to have an equal groups problem. And I know my product. I know I have 50 marbles, so I'm just going to put a division sign there because that's going to let me know that I have a missing number in each group or a known product. Then it says each bag has half as many rocks as marbles. When I'm halving something, if I'm halving an apple, all that means is I'm dividing something into 2. So here I'm dividing the number of rocks into 2 to find out how many marbles. I'm dividing the marbles into 2 to find out how many rocks we have. So I'm going to put a 2. This is also equal groups, and we're also dividing because we see half. That means we're going to be dividing by 2. And that's another indication that we have an equal group schema with a known product. So now that I have written my 1 and 2 and my 2 schemas, before I go to my second S, I need to figure out which equation I'm using. So I'm going to look at my multi-step word problem schema map version 3 and look to see where I'm dividing twice. I see here my last example, I'm dividing twice, or my example where I have an equal groups with a known product followed by an equal groups with a known product again. So I'm going to go ahead and write that equation, P divided by GR in parentheses divided by GR again is the same as blank. Now I can check off that S, and now I can plug in my numbers. I know I have 50 marbles, check that off, and I'm dividing or sharing them equally into 5 bags to figure out how many marbles are in each bag. So I'm going to check that off. And then here it says half. Well, I know that half means I'm dividing in 2, so 2 is actually the number that I'm going to put there. So you might have to have a little learning, teaching moment with students where you talk about half means we're cutting something in 2 or dividing something in 2. Thirds means we're dividing in 3. Fourths means we're dividing in 4th, etc. So now here I'm going to do whatever is in parentheses first because parentheses come first in our order of operations. 50 divided by 5, I know that's 10. If students need to use the multiplication table math, absolutely can do that, but I'm doing the mental math there. And then I'm going to bring down my divided by 2. 10 divided by 2 equals 5, or is the same as 5. Again, if students want to use that multiplication table math, they can as well. I have my number answer, my label. I wrote rocks, so I'm going to write that here. I'm going to darken that. I have solved the problem. Now, the last thing I need to do is check for reasonableness. I need to make sure that my number answer and my label answer make sense. So let's take a look. If we have 50 marbles and we're sharing them equally into 5 bags, it makes sense that I would have 10 marbles in each bag. And then if there are half as many rocks as marbles, 10 divided by 2, because we're cutting in half or dividing in half, it makes sense that I would have 5. My number answer makes sense. My label answer, rocks, that matches what I underlined. So I know I crushed this problem, and you did an outstanding job. We're going to put a check mark there. Nice job solving this third example of an equal groups problem where we divided twice because we had an equal groups with a known product 2 times. Thank you so much for taking the time to view this Pirate Math Equation Quest video from our multi-step word problem intervention with total difference, change, and equal group schemas. I enjoyed presenting on multi-step equal groups and equal groups word problems. I'd like to take a moment to thank the Institute of Education Sciences, the University of Texas at Austin, and the Meadows Center for Preventing Educational Risk. Without their support, this work would not be possible. I look forward to seeing you in another video.